Hello everyone. Uh, on this video, I will explain on how to construct a histogram for the qualitative data. So the qualitative data means a counting data. So on the previous video, I explained on how to construct a histogram for the continuous data. So here we have an example of a sample of 120 individuals and they own motorcycles, and we ask them to name the manufacturer of his or her bike. So we have Honda, Yamaha, Kawasaki, Suzuki, and it is very clear that this data is counting data because you cannot have -1 people on Honda motorcycle, or you cannot have 2.5 people on Yamaha motorcycle. So I will show you how to construct a histogram for the data like this. And I already copied the data to spreadsheet. And the first thing that we need to check is to check the total of the observation. So we put total over here and we calculate it. We just sum, and here it is. So the total is correct. So we have 120 observation. And in order to develop the histogram with Microsoft Excel, you just go to insert, and the histogram for the counting data, it is just the bar chart. So you go to column, and then you just select the first type of the column, and then you right click and select the data, and you need to add your entries. You add it, and the name of the series is the bike owner, and the value is the number except the total. And then you click OK, and then the label for the horizontal axis is the manufacturer. Okay, and this is it. This is the bar chart or the histogram. This is an example of the histogram or bar chart for the counting data. And I think this conclude our discussion on the histogram. And the next thing that I want to discuss, it is the other type of picture or graph that we can use to present data. And the name of that technique is the box plot. So with a box plot, you can present the quartiles of the observation. So we can present the quartile 1, quartile 2, and quartile 3 of the observation. And based on the box plot, we can also see the distribution of the data, the range of the data. So there are two types of box plot, the minimum and the first one is the minimum and maximum box plot, and the second one we call it as the Tukey box plot. Here are how the box plot look like. So the first picture, it is the minimum and maximum box plot. So you see that the plot is a box with this side of the box is the quartile 3, and here the line in the middle, it is the median or quartile 2, and this side of the box plot is the quartile 1. And the line over here, the line above the quartile 3, we call it as the whisker. And with the minimum and maximum box plot, the end point of the whisker is the maximum value. And here we have also a whisker below the quartile 1, and the end point of that whisker is the minimum value in the observation. That the minimum and maximum box plot. And here it is how the Tukey box plot looks like. So it is the same that we have a box with the this side of the box is the third quartile, and the line in the middle it is the second quartile, and the line over here, the side over here of the box is the first quartile. And in Tukey box plot we also have whisker. We have a whisker above the third quartile, and we also have a whisker below the first quartile. But the length of the whisker in the Tukey box plot, so the whisker above the third quartile, it extends to the largest data point within 1.5 interquartile range from the third quartile. So with the Tukey box plot, we need to calculate the IQR first, and then we times that IQR with 1.5. And the length of the whisker above the third quartile, it is the largest data point within 1.5 times the interquartile range. And similarly, the length of the quartile below the length of the whisker below the first quartile, so it is the smallest data point within 1.5 interquartile range from the first quartile. And with the Tukey box plot, we can see the outliers. So the outliers means the data that have extremes value. So we're gonna have outliers above the first whisker, and we're gonna also have the outliers below the second whisker. What I mean by the first whisker is the first one is the whisker above the third quartile, and the second whisker is the whisker below the first quartile. So any data that not lie on the box or on the whisker, so we call them as the outliers. Okay, and I'm gonna give you an example on how to develop a box plot. Okay, so let's use this data that we use to calculate the stem and leaf, and we already know based on our previous calculation for this data. So we know the quartile 1, so we know the quartile 1 of the data is 143.5. The quartile 2 of the data is 161.5, and the third quartile of the data is 181. And we also know that the minimum value, so this is the X max, sorry, I'm gonna put X max equal 245, and the X minimum equal 76. And we know the IQR equal 37.5. Okay, so the first box plot that we're going to calculate, that is the maximum minimum box plot. So max, we're going to develop the max min box plot. Okay, so the first thing that we need to have is the box. Okay, we're gonna have the box, and here will be the quartile 1, and that value is 143. I'm gonna make it smaller, the size of the phone. Okay, so that is 143.5. That's the quarter 1. The quarter 3, it is 181, and the quarter 2 is 161.5. So it is 161, so it is about here. Okay, so it is the third, it is the median, or the second quarter, it is 161.5. Okay, now with the max and min, and now the next thing that we need to do is to plot the whisker. So the whisker above the third quartile, so the end point of it is the 245. So I'm just gonna put the whisker over here. Okay, and the end point of the whisker of the max min box plot is 145. Okay, and for the next whisker below the first quartile, it is just 76. Okay, okay, so that is the max and min box plot. It is very easy to construct. Okay, now let's make the two key box plot for the same data. So I'm gonna put here the key box plot. The key box plot. Okay. Okay. Now the first thing that we need to make is the box. So I'll try to make the same size. Okay, so I'm trying to make the size of the box is the same. Okay, so because we are using the same set of data, so here is the first quartile. Okay, and the value is 143.5, and then we have the median for the second quartile, and the value is 166.5. I'm gonna put it over here, 161.5, and then we have the third quartile over here, and that is 181. Now in order to plot the whisker, we need to do some calculation. We need to know what is 1.5 times 37.5. So let's do over here 1.5 times 37.5, which is the interquartile range. It is 56.25. Okay, so 56.25. Okay, now for the whisker above the quartile 3, so we need to the quartile 3 is 181, and plus 1.5 times 37.5, 56.25, and that's equal, so I add the number by 181 plus this guy, and that is 237.25. Okay, so I need to find in the data the largest data between 181 to between 181 and 237.25. So let me see the original data. Okay, okay, this is the data. Okay, I'm gonna copy the data and paste it, and then I'm gonna sort the data from the smallest to the largest. Okay, let's see what is the, okay, so 237.25. What is the largest data between 181 and 237.25? Here, 237. Okay, so now we can make the whisker, and the endpoint of the whisker is 237. Okay, 237. And remember, we have a data above 237, which is 245. So we have 245, and that 245 is the outliers. So it is 245, and this guy is the outliers. So when you have an outlier, you have something to think about the data, why the outliers happen. So if it is the what the quality of your product, and you have an outliers, and you need to think what happened so that I have that kind of quality, why I have that outliers. Maybe there is a problem with the materials, maybe there is a problem with the machine, or maybe there's a problem with the worker. So when you have an outliers, you need to think about it, you need to analyze why you have an outliers. Okay, now we need to calculate we need to plot the next whisker. Okay, so we need to know, so 143.5, that is your first quartile, and then what is 1.5 IQR below your first quartile? So that will be 143.5 minus 56.25. Okay, so it's 143.5 minus 56.25, 87.25. Okay, so that's 87.25. The thing that you need to do, you need to go to the original data and find the smallest data between 87.25 and 143.5. This is it. Okay, so the smallest data between your first quartile and your between your first quartile and 87.25, the largest data, sorry, it is 87. Okay, so the whisker here, so here the value of it is 87. Okay, okay, and remember you have 76 here below 87, so that's gonna be your outliers. Okay, okay, and you have 76 over here, and here you have also an outliers below the whisker, so this is outlier. Okay, okay, so with the box plot, when you have two set of observations, you can compare the observation by using the box plot right away. So based on, so you plot the box plot for the first observation, maybe you take that observation today, and then you take the observation tomorrow also, and when you have the two sets of data for today and for tomorrow, you make the box plot and you compare the box plot. The box plot that have a longer box and the longer whisker, that means we have a that means on that data you have more variation. Okay, so I'm gonna give you an illustration over here. So this is the first box plot, for example. Okay, and we also have the second box plot. Okay, this is the box plot number 2. Okay, so it is very clear that the data that we use to make the second box plot has more variation than the data that we use to make the first box plot. I think that is it, and thank you very much.